Okay, question 14. A circle has center O and radius 6. PQ and R are points on the circumference with the angle POQ greater or equal to pi over 2. Okay, so it seems like the angle at the center is obtuse. Okay, the area of the triangle POQ is 9 root 3. And what's the greatest possible area of the triangle PRQ? Okay, so again, for me, I would definitely draw a diagram because I just can't see it. So let me try to construct this. So if O is here, POQ, so P is here and maybe Q is here then. All right. And then we know this is obtuse. Fine, I've drawn it obtuse. And then R, okay, where would R be? I want to maximize the area, right? So I definitely want R to be right above here, right? That maximizes the height of the triangle, right? The base of the triangle must be QP. So if you want the height of the triangle to be maximized, you're going to make sure that the R is bang on the middle, right above the center, right? Right above. Okay, so my triangle that I'm interested in is here. Cool. Okay, so if I want to find area of triangles, then I might be interested in some angles, right? Because the formula is half BC sine the theta, right? So how could I find here? What's the angle here? I know that area of triangle POQ is 9 root 3 and the radius is 6. So both of these sides are 6. Yeah, so half 6 sine theta equals what's the area? 9 root 3. Okay, so by some algebra, sine theta would be root 3 over 2. And remember, you might be tempted to say theta is 60, yeah, because that's the value we sort of memorized, but then it's obtuse, right? So if you think of the sine graph, what's the obtuse angle, which gives me the same value? It's 120, right? Okay, so this will be 120. Fine, so that's obtuse, right? So if that's 120, then it follows that this is 30 and this is 30, right? And if they're symmetrical, then all of these angles are also 120 here. All right, so therefore the big triangle, if you do some simple geometry, is an equilateral triangle. It becomes equilateral, right? Okay, so how do I figure out the area of an equilateral triangle? First of all, I'm going to know the side lengths of it, right? So what are the side lengths of it? So you could do whatever you like. For example, you could do let me use another pen. If you cut a triangle here and you find this side, yeah, if you multiply by 2, then you'll be fine. For example, you could go like 6 cos 30 and multiply by 2. Yeah, so if you go 6 cos 30 and multiply by 2, and then that gives you something like, I don't know, 6 root 3, right? So that's the whole length of 6 root 3. And then you want to calculate the area of the equilateral triangle. So that becomes half 6 root 3 sine 60 degrees. Yeah, because each angle is 60 degrees in an equilateral triangle. Okay, and then should be fine, right? I think that gives me 18 root 3 from there. All right, is it 18 root 3? Let me do the maths properly. So, no, 27 root 3. Sorry about that. Okay, 27 root 3. Okay, the other way that you could have gone for it, yeah, is that you observe that the 3 smaller triangles are actually perfectly symmetrical, right? As in this original triangle that we were dealing with, right? It's duplicated twice. On top here, once, and then twice here. Alright, you could have also observed that. So therefore the area would just have been 3 times the original, which would have been 3 times 9 root 3, which also gives me 27 root 3. Alright, so that's the more straightforward way of getting it, I suppose. But in both ways get you to the same place. Alright, so final answer would be D, 27 root 3.